Let's now try to solve the second problem, which is designing a simple calculator. It is saying create a calculator that takes two numbers and an atom, and the atom is going to be one of these four: add, subtract, multiply, divide. It should produce the result as a tuple of either OK result or error explanation. So let's see how we can design this function. The way we are going to handle the error, I think, is going to be divided into two different options. If we are dividing by 0, then it should produce an error with a message saying cannot divide by 0. But in all other cases, we are going to produce an error tuple with a message saying invalid operation. So at this point, again, I would encourage you to pause the video and try this for yourself. And then we can come back and look at the implementation together. So here we are in the editor. We are in our math module, and I want to point out that in the test file, I have already added some test cases for this calculate function. So we're saying if we have an addition operation, it should produce a tuple of OK and 5. If it is a subtract operation, OK and -1 for 2 and 3. If it is multiply, OK and 6. If it is divide, OK and 0.5. And then finally, two error cases where in the first one, we are dividing by 0 and we produce the error message saying cannot divide by 0. And then for the second one, we are producing invalid operation. So all other cases that do not fit into the above, we are going to produce invalid operation. So let's see how we can design this function. We'll start with spec, and our function is called calculate. It's going to take two numbers and an atom, and it's going to produce a tuple of OK and a number, or a tuple of error and a string. So this becomes our function signature. So let's write the purpose statement. Produce the result of given operation on the two given numbers. We're going to say result is OK and number for a valid operation. Result is error and cannot divide by 0 for division by 0, and result is error, invalid operation for all other cases. So this becomes our purpose statement with some expectation of what the result is going to be in different cases. Then we're going to write the stub here, and and that starts with the definition for calculator. So we're going to say xy and operation, and we're going to say let's produce a result that matches with one of the expected types. So here we are matching with this OK and a number, so that becomes the stub, and therefore we are able to run our tests. So I'm going to start with mixed test, and I'm saying all my 6 tests related to this function fail, and that is expected because I am just producing a fixed tuple of OK and 0 all the time. Moving back to the implementation now, let's see. I think we can do a pattern matching on this. We are going to say if this is add, right? If this is add, then produce x plus y, right? And if this is subtract, then produce x minus y. And then if it is multiply, and then produce x times y. And now we are going to check for the failure case, right? So we're going to say if it is 0 and we are dividing, if the second value is 0, so we're going to produce error, and from the purpose statement we are going to say cannot divide by 0. And notice that Elixir is saying you are not using this x value, so we can discard this match. So we are doing a pattern matching, but we don't need this value in our function body, and therefore we are discarding this. In other cases of divide, we are actually going to divide. So we are going to say OK, and x divided by y. And then the last case is going to be any other operation. So we are saying it doesn't matter what the 3 values are, we are going to produce an error saying invalid operation. So these are our 6 function clauses that would allow us to do the computation and provide the results that we are expecting based on our tests, as well as the purpose statement written up here. Let's go back and run our mixed test, and we still have 2 failures. So some tests are passing, that is good. Let's see where the failure is. Okay, so this is a mismatch in the messages, cannot divide by 0, that is 1. And then the second failure is operation, again the mismatch in the expected results. So I will go and change this in the test. So the first thing we want to do is, this was saying cannot divide was capital, and then there was 0 here, and a period here. So let's go back and rerun our tests, and now all our 6 tests pass. So there you have it, your calculate function that takes 3 parameters. The first 2 are numbers and third one is an atom, and it produces a tuple depending on what the situation is. So I hope this is helpful, gives you some idea of how to work with tuples in Elixir. Before we go, I want to note that the order of function clauses matter in Elixir, because Elixir will check for the pattern match and execute the function that matches a particular pattern, starting with top going all the way to the end. So it will first test this clause, and if it matches, it will run. Otherwise, it will move on to the next one. And with that, it will go all the way to the end. So this has an implication on this division operation. So note that we have 2 divide clauses, one with a value match of 0 and other with general division. If I flip this order, meaning the XY divide comes before the underscore 0 divide, then the underscore 0 divide will never be executed, because this is a special case of XY divide. So this pattern will always be matched by XY divide, and this function will be called always, and we will never reach this clause. Let's see that in motion here. So here I flip the order, and going back to mix test, I see that now the test fails because it is saying arithmetic error, and that is because it is trying to execute the 0 division with this operation. So we don't want that, so I bring that back to its original state and run the mix test and make sure the test passes again. So bottom line is, with multi-clause functions, the order matters, so you have to pay attention to the order of the function clauses.